Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have got to know about how the aryl halides are basically less reactive than compared to that of the alkyl halides. And based on that theory, we are going to talk about that how does an substitution reaction is very much effective if an electron withdrawing group is present in the aryl halide. So let us talk about that. So this is a lecture that I am going to talk about that how does the electron withdrawing groups, they basically play a very effective role in increasing the reactivity or increasing the activity of the aryl halides, in which basically they are attached to, that is at the ortho position or at the para position with respect to that of the halogen atom that has been attached to the aromatic ring. So based on that, we are going to talk about the first thing, that is what happens if basically the electron withdrawing groups are basically attached on the ortho position and the para position with respect to that of the halogen atom that has been attached to the carbon atom. So let us talk about that. Suppose if we consider a particular electron withdrawing groups, and there are various electron withdrawing groups. So that is an example that I am going to talk about. For example, if I would say that is a nitro group, that is NO2 group. This is basically an electron withdrawing group. Talking about the another one, that is carboxyl group, and the last one, suppose in this case, that is cyanide group or cyano group. So this is the thing, or these are the substituents. Basically they are electron withdrawing groups, and what happens if they are being attached to the haloarenes. So let us talk about this with an example. That is what I am going to talk about here. Is basically if I take a nitro group and that is been attached to that of the chlorobenzene at the ortho position and at the para position. So let us see what will happen in that case and how can it increase or it could decrease the reactivity. That is what we are going to clear about. So now let us talk about that. Suppose if we have basically a chlorobenzene, that is, this is how I am representing over here. So this is the chlorobenzene that we have, and at the that is, I'm just mentioning over here. And suppose at the ortho position, suppose an electron withdrawing group like NO2 is been attached, and the structure of NO2 can be given as in this way. So this is basically the electron withdrawing group, basically the nitro group that has been attached to the aryl halide. And since we know that it can undergo the that is substitution reaction also, but at drastic condition. But what happens if an electron withdrawing group is been present on, that is on the ortho position, or it has been attached to the aryl halide? Actually, it increases the reactivity or it increases the activity of the benzene ring, and now in this case basically the possibility of the substitution reaction is more, and therefore basically the substitution reaction can take place very easily. So suppose in this case if we are going to treat it with that is NaOH or a base. So in this case basically we are talking about the substitution reaction, basically the OH minus ions, that is what it will replace this Cl minus ion so as to form, that is this product, and it requires certain conditions also. So suppose this is the condition that we have put over here. So how does it increases the reactivity, or how does it increase the activity? So it has been generally found that whenever the electron withdrawing group, if they are present at the ortho position or if they are present at the para position, they can increase the reactivity. How? Let us see the resonance of this one. So the structure of, that is ortho nitro chlorobenzene, suppose if this is what I have mentioned over here. And if this has to undergo, that is a substitution reaction with that of the OH, suppose if we are using OH minus ion, so therefore that would attack basically the group that would be present over here, or it has to undergo, that is a substitution reaction. So therefore we could find that there is a possible product that we could get is basically here it is Cl that has been present over here. And talking about the next thing, because even here suppose the OH has been present, so we could say that there would be a bond shifting over here, and that is how we could find that at ortho position there is a negative charge. So here we could see that the electron delocalization takes place over here, and that's the reason that here there will be a negative charge that will be present over here. But meanwhile, we could also draw the structure of the NO2 as possible, like this way. And here it would be positive charge for this nitrogen atom. And now the other atoms that are being present over here, or the other pi bonds that are being present over here, even they can undergo delocalization. And this is how we are going to talk about the resonating structure that we could observe over here. So therefore, this is a very fast process, and this is what we could get over here. So this is a very slow process that we could get over here, and that is what we are going to. That is what we are getting, the resonating structure. And therefore, this resonating structure that we could get over here is basically, I would write it over here. That is, here there will be double bond formation, but here there will be a negative charge. But meanwhile, they're talking about the other one, that is, they are present here as it is. And here, because there is also a double bond over here, and the rest of the thing is, you can sense Cl as well as OH. And now, suppose again another delocalization takes place over here in this way, where we could find, that is, the structure where this has been shifted on this bond, while meanwhile we could say that there will be negative charge that will be present over here, and here there is Cl along with that of the OH, and here basically there was a double bond that was being present according to the resonating structure that we have, and this is what we have got. And again, suppose this will ultimately, basically this will shift on this bond, meanwhile here basically Cl was being present, and therefore we have to give a substitution action. So therefore these are the resonating structure that we have got over here. So ultimately we can write the hybrid structure also, where we could find that is the negative charge is basically delocalizing, or it has been shifting in the benzene ring, and that's the reason that ultimately we could get a product basically, and therefore that kind of reaction, it would be basically a fast process, so as to obtain basically the main product that we are where we are concerned with, that is, now the shifting has taken place in such a manner that we could get, that is, NO2 over here as well as OH along with that of, that is, Cl minus. So this is the substitution reaction that we have talked about. So why does this kind of basically the benzene ring that gets activated because of the nitro group? So if you observe in the resonating structure itself, we could find that the negatively charged species that are present at the ortho position over here, as you could see, as well as on the para position. But meanwhile, this nitro group, it is basically an electron withdrawing group, and that's the reason that the negative charged or the negatively charged benzene ring that it has been created. So because of the electron withdrawing group that have been present on the ortho position, so now that gets balanced, and that is how, because of which basically the Cl atom gets removed, and this is how we could get the possible, or we could find that the activity increases. So if we are also talking about, suppose if this is somewhere it was being nitro group that was present on the ortho position, and what happens if basically the nitro group is present on the para position? Let us see whether this kind of reason that we could get or not. So let us talk about the resonating structures when we are talking about the hydrolysis of para nitrochlorobenzene. So that could be mentioned as, suppose this is what I have to represent, where we could find, that is, the nitro group is present at the para position. So let me represent it with this one. So this is it, and suppose if it has to undergo, that is, hydrolysis, or if I'm reacting with that of the OH minus ion or with the base. So ultimately, basically, it will give a such kind of a fast process. Ultimately, it will give us a slow process where we could find, that is, the resonating structure. And suppose if this OH gets attacked on, because it has to substitute the position where the Cl has been present. So the force in that case, we could get the possible structures that are, so here it is the Cl that has been present, and here suppose somehow the OH has been replacing it. So therefore this is the OH that has been present over here. So therefore this is the resonating structure that I'm talking about, and there will be a delocalization of electrons or pi electrons. So here is basically what it happens, and we could get basically a negative charge over here. But meanwhile, the bond, the pi bond here, it will remain as it is, and this is how I could get the structure. And again the possibility that is there will be shifting of electron, and that is what we are going to talk about, the resonating structures. And this is the shifting of electrons that takes place over here, and somehow we could get the structure which is, now here there will be negative charge over here, so let me represent it here itself. And now this is nitrogen, which is basically positive over here, and this is what it is. And again, this is a double bond that is been present over here, and here it is OH, and along with that of this is Cl. Again, this will show that is a resonating structure where the delocalization of electron would take place in such a manner that the resonating structure that we could get over here is basically, it will be in this form, where we could find double bond over here, and the negative charge is on this carbon atom. So therefore this is OH, this is Cl, and now here it is basically the nitro group that was been present. And now this is the process basically where the negative charged basically it will deposit on this bond, and so as to form a carbon-carbon double bond. But meanwhile here the Cl, it will be get eliminated or it will be removed. So this is a process that where we have found that these are the resonating structures, and ultimately a fast process will happen in such a way that we could get a product, and that product is basically that is para nitrophenol. So this is what we will get. But this kind of process, it doesn't require a drastic condition that we have did during the study of the previous lecture. So this is what it happens, and it activates the basically it activates the benzene ring. If you observe, that is the negatively charged species, they are present at the ortho position, the para position, and again at the ortho position. So this is somewhere the electron withdrawing group, like that is the NO2 group. So they stabilizes the electron density on the benzene ring, and that is how it basically activates the reaction so as to give a substitution reaction. So this is what I was talking about. And talking about the meta position, suppose if an electron withdrawing group has been present in the meta position, so therefore this kind of behavior that won't be observed, and that is how it has been clearly mentioned over here, that is the nitro groups, or basically any kind of electron withdrawing group, if they are present at the ortho or they are present at the para position, they could increase the activity or activity of the during, that is, nucleophilic substitution reaction. So that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and you'll share this video with your friends. So till then, don't forget to subscribe Ekeeda channel. Thank you so much.